And the area quantities we might pull out are things like pavement or base materials if we want to quantify them by area instead of volume. And we'd also pull out things like linear quantities. This could be curb or guardrail or anything with a linear quantification. So with that, I'm going to jump into Civil 3D, and we're going to look at a number of things here. To start with, I've got a corridor on the screen here. And if I hadn't mentioned it before, I will take some questions if they're not too time-consuming. So if there isn't something that's clear while I'm going through this, feel free to shoot a question in. If they're too lengthy, I won't address them now, but I will respond to you guys afterwards. So feel free, shoot in any questions you might have. So I've got a corridor here, fairly basic corridor with some intersections and a number of different regions in it. We are glossing over corridor basics. We're moving right on to corridor earthwork and quantities. What I have in this corridor, if I go into my corridor surfaces, are a couple surfaces defined. One is my finished grade surface, and very commonly that's defined by top links. It might also be defined by some feature lines, such as back a curb, flow line, things like that. That's always a nice way to get more control on your corridor surface. So my datum surface, though, this is defined with datum links. And datum links are what represent the bottom of all my subassemblies, or the bottom of my typical section. I'll show you what that is visually in just a second, but a good practice with this is to always set this to bottom links and to also define this as add as break lines. What this does is it forces triangulation right along those corridor links. It doesn't really make a difference in straight sections, but it does make a difference in intersections and areas where you have baselines that are non-parallel. I have a boundary defined for each of those as the corridor extends. So I can turn this on for just a second, just so you can see what we're working with. And we'll look at my datum surface in 3D, just so we're all on the same page. And so, just in section view, here's my assembly. My datum surface is everything running along the bottom of this typical section. That's what we're calling a datum surface. And to look at it in 3D, if I take my surface, take a peek at it, you can see along here, for example, I've got that steep vertical face behind the back of curb, and I'm going underneath the granular section here, okay? So cut and fill quantities we may want to get. We want to quantify cut and fill outside of our material imports. So I need to compare a surface to another surface. Here's just a hypothetical. If I had existing ground surface running like this, I would compare that to datum surface, and that would give me fill quantities. So fill is everything I need to build up to my typical section. Cut would be the reverse, where it's everything underneath my existing surface all the way down to my datum surface. So just a visual of what we're dealing with there. So the most basic way, I'll do this one fairly briefly, is to use Volumes Dashboard. So I can go right to Volumes Dashboard, and I create a volume surface, and I'll call this Cut Fill. We won't give it a style because we don't need to see this, we just need to get quantities from it. And all a volume surface is a comparison of two other surfaces. So my base surface is my existing surface, and my comparison is that datum. Okay, so again, I'm getting cuts and fills that subtract out the material quantities, the select materials I'm bringing in. And we could certainly have a fill factor as well. So those areas behind the curb here, or over here where there's some fill, there will be some compaction. We can account for that with a fill factor. And I click on this, and I get cut and fill with that fill factor, and I get a net as well. That is Volumes Dashboard. It's fairly straightforward, fairly simple, and it works for many cases when you want just a complete lump sum number. You can take it a little further and you can add subregions or bounded volumes up here, and you can draw a polyline to separate those cuts and fills from one area to the next. But for the most part, it's lump sum quantities. So how do we use sample lines to do this? And we get per station quantities. Let me start by turning off this datum surface so it's a little easier to see. And I'm going to create some sample lines. So sample lines are objects that you wouldn't typically print in your construction documents, but they're objects that you need to do one of two things: to generate cross sections or to generate material or earthwork quantities from your corridor. So if you haven't used sample lines before, I'm going to go right here to sample lines. It prompts me for an alignment. I will pick my center line alignment, and it's going to create a sample line group. So I'm going to give this the name of my parent alignment. This is a nice trick. You should put this right into your template so it always names it, parent alignment. And then I've got all these data sources. So this is basically scanning the drawing, finding data sources that I could have in my sample lines. I've got some other things in here I don't need to use. What I'm mostly concerned with is my existing surface, my datum surface, and my corridor. So I'm going to turn off those other items. So one question came in: is topsoil stripping part of existing ground? You would need another surface to quantify topsoil stripping. It would be similar. We could do some surface pasting and then a raised lower of a surface without some more detail on what you're asking. Those are some of the methods for topsoil stripping. So moving on here, I've got my corridor surface, my corridor, my datum surface, and my existing surface. I'm going to go ahead and hit OK, and it launches me right into this sample lines creation workflow. Now I can start picking randomly here, or I can go to by range of stations and define the range along which I want to create sample lines. So I'm going to go a station range here. I'm going to start at my construction limits right here, and I'm going to go all the way to the other end down here. I'm going to sample at 25-foot intervals along tangents and curves, and I'm also going to go start right at the beginning and the end of the station range I defined up here. Now this increment here, it's 25 feet. As I said, sample lines are for cross sections and they're for quantities in this way. If you want to sample your materials at a different interval, meaning more accurately than your cross sections are, you end up having to create two separate sample line groups. So if I want cross sections at 50 feet, but I want to pull material quantities at a more detailed level than just sampling every 50 feet, you have to create two different sample line groups. So I'm keeping this at 25 and then hitting OK. You do have some control over the sample lines that you make sections from at the time of section creation, but I see a lot of folks just creating two separate sample line groups. Okay, so it makes sample lines. If I hit enter, I see it populate the station, the label, and everything on there. Now what this does, it's going to sample the data right here at each and every sample line, and it's going to give me a couple different methods for calculating the volumes in between those two. So let's jump right into that. If I pick on a sample line, I can go right to compute materials, and it prompts me. I've got a sample line group and alignment to choose. Those are the only ones in the drawing, so I'll hit OK. And then I've got quantity takeoff criteria. Right now I'm after cut and fill. Cut and fill is simply the comparison we had just made with volumes dashboard. It's datum surface compared to existing. And so that's why it's prompting me down here to specify what my existing is, and also to specify what my datum is. That is the surface I have named here, corridor 5 datum. A couple other items up here. Volume calculation method. There's three methods in here, and most of you are probably familiar with the average end area method. This is a traditional method where it calculates the end area at one station, calculates the end area at another station, takes the average of the two, and multiplies it by the distance between those. That's average and area method. It works for non-digital methods. You know, I used to do this stuff on paper, manually calculate those areas. It's doing that same thing here. You do have a couple other options though. Prismoidal is one that's slightly more accurate. It calculates an intermediate sample in between the two sample lines, so you get a little bit more accuracy. And then this last one here, Composite Volume, this one actually takes the portion of the surface within those two sample lines, the portion of the two surfaces, and calculates a true volume in the same way that a volumes dashboard will. Now, will they make much of a difference on a fairly straightforward road? No, not much, but if I get a chance, I'll switch those and you'll see a slight change in values when we go from average and area to composite. So in a nutshell, composite, more accurate, but certainly more calculations happening there. I'll leave it at average and area for now and hit OK. I've computed materials when I hit OK. And just to see what we had created, I'm going to go into my sample line group properties and look at my material list. What I've created here is ground removed and ground fill. Now you can build this stuff manually, but I had a cut and fill style. That was this one right here, cut and fill. That's what we just defined. I can define these manually instead, and all it is to come in here and say if I have existing and datum, what is the value I'm trying to quantify? Is it below or above existing? Is it below or above datum? So I took a nice little shortcut. It's using criteria sets. These come right in your out-of-the-box template. That's what these are right here. And they have predefined material lists like this. Again, I have fill factors and such that I could add in there. I'm going to hit OK. Now to see these actual values, we have to create a table, and that would be a total volume table. So I'm going to click on total volume table. My table style will be cut and fill. My material list will be the one I just defined, and we'll turn off split tables so that we just get one set of rows. And I'll drop this off to the right here. And I get a value down here. I get cumulative cut and cumulative fill, and I get values as I go along my corridor. Okay, so as I said, this is per station quantities. I get cumulative, I get a total down here. So let's go ahead and make a quick change here. We're at 212, 26, 85. If we change the method, sample line group properties, instead of average and area, go to composite volume. It will calculate it slightly differently, and these two values you should see down here change slightly. That is a more accurate method, but like I said, often unnecessary. So we can define quantities in all sorts of ways. We can compare datum surface to EG, FG to something, any number of options. Oftentimes you've got some kind of select fill under your primary section, and then perhaps some common fill over here. Do you want to quantify that differently? You'd have to define separate surfaces in that way to do that. But it all works the same way, comparing two surfaces, defining them in your material list. Now, how do you handle areas like this? And I've got an intersection. If I'm just sampling right in the middle here, it's just cutting section or sampling right between here. And it's calculating data that I don't necessarily want. So a couple quick questions. Can the data be exported to Excel? And the answer is yes. So I had done a Civil 3D table, but I also can create a volume report. And when I do this, I can save this out and get a table like this. This stuff is very easily copied and pasted into Excel to work with in that way. The one advantage you have with the Civil 3D tables, they're dynamic, so that changes to corridors and sample line properties will reflect in there, but obviously Excel gives you a lot more to work with. So I just want to show you quickly here How do we handle this area? Well, we need to break this up. We need to define what area is calculated by this set of sample lines and what area is calculated by this incoming road. And what we'd want to do is we'd want to take a line, I'm going to say it's roughly about right here, and south of that is going to be calculated by sample lines from this north-south road, and everything else by the other ones. And so what would this look like? It would be something like this. First, I need to create a couple sample lines, a few more sample lines, and these need to go kind of right at that transition area. I'm going to put another one over here. Okay. And this one I meant to bring out to 50 feet. Okay. And now I can take the sample lines in the middle here from 475 to 550, and I can take the right side and bring them down. And I can do this all at once if I go into my sample line group properties. Sample line group properties. I can go to sample lines. I can go to 475 to 550 and set this to 15 feet on the right. Okay, now those sample lines are tucked in there. Now it's important how you quantify this. For example, if we look over here, it's going to calculate a quantity there and also one right here, and it's going to average the two. So it's going to, technically it's going to calculate some volume in this area here. So to be truly accurate with this, we'd actually want to drop in one more sample line really close, so we pick up that transition. Okay. As I add sample lines, my quantities will update accordingly. So I have slightly different values there. It's responding to the differences. So then I'd create another set of sample lines, put it along this alignment, and calculate that area. I could take that sample line right along the edge here of this side road, and I'd be able to do things like this with the sample line. I'd be able to skew the sample line. Okay, looking at our sample line group properties again, I can pull material quantities out of here. So this would be like class 5 aggregate. I can come in here and add a new material. We can call this class 5. And this material is a different type. It's not based on two surfaces. It's what's called a structure. Terminology is a little confusing there, but nevertheless, you want to select structure. And then you want to grab your corridor shapes. I might be missing something here. Let me go back into my sample line group. I'm missing my corridor shapes. So you have two data types here normally. One is surfaces, another one is corridor shapes. And I'm not getting that. And what corridor shapes are, I alluded to briefly, are these shaded areas in here. So I want to be able to reference this base corridor shape in my sample line groups. Let me rebuild my corridor one more time. Not sure why those are not showing up. Because I'm giving a webinar. That's why they don't show up. Sample line groups. Sorry about that, folks. I promise when you do it, corridor shapes will show up here. Not sure what's missing there. Try this one more time. Oh, you know what? I think it is my calculation method. Yeah, I'm sorry about that. The composite volume method only works for surfaces. So if your criteria set or your material list is set to composite volume, you unfortunately can't do the corridor shape method. So if I go back to average end area, I will then have the option to do corridor shapes. And I could grab my base corridor shape, add that in here, hit OK, and I can now get base materials. Again, from the Analyze tab, go to my Material Volume table and calculate Class 5. Can drop this over here, and I get a total material volume, 425, and that's based on my entire sample line. So at 425, what we're quantifying then, again, is this shape in here. So if I were to grab my primary assembly and change the base thickness, we should see that value change as well. So I've got 4 inches, let's go to 6 inches of base material. So right now I have a total of 425, that's my cumulative volume. And if I go and rebuild my corridor, we will see this bump up by 30% or so. Okay, another question came in, can you combine material quantities and earthwork quantities into one table? No, unfortunately you can't. I don't know why you can't do it. I've tried 100 different ways to make it work, short of stacking your tables next to each other and formatting them a certain way, or pushing it all out to Excel. You can't get them in one nice, neat, and tidy table. So, nevertheless, you can get the quantities themselves. All right, that is earthwork or volume quantities. Let's look at another way to quantify items in your corridor, and that is the QTO Manager. If I click on this, my QTO Manager opens up. And what this is right here, this is what I've done is opened up a pay item file. And a pay item file, I've got just a sample one that actually comes with Civil 3D. I'll go to Windows Explorer and open that up. All this thing is a CSV file. So just save right out of Excel. And you can create these on your own. You can format these any way you want. The key thing here is to have 3 columns: a pay item column, description, and a unit. And these units have to follow a certain syntax. This is an odd thing that's easily missed. This syntax for your units needs to follow the units defined in this file right in here, inside the units folder, and then QTO, it's an XML file. If I were to open this up, and I throw that to the right side, if I look at my units, and I've got lump sum and acre and things like this. So I have acre over here. Acre is a quantity, a hard-coded unit defined in Civil 3D based on this XML file. So what does this mean? When I calculate quantities and it has a unit type of acre in my QTO Manager, it will spit out values in acreage, even though my default drawing units are feet. Okay. It won't work if my unit says acres, because acres is not defined in the XML. So you have to follow the syntax that's in this file. When in doubt, just always follow the syntax that's in this default CSV that comes with Civil 3D. Every option you should possibly need is in there. But you know, don't take the liberty to just kind of name these any way you want, because you won't get it in the units that you're expecting. All right, little behind the scenes thing there. So what I'm doing is pathing to that CSV. It comes in here. Here's those same 3 columns. And QTO Manager works fairly simply. Say, even without a corridor, I can use this thing. So say I had some a couple polylines here, and I'll draw these 100 feet long. Okay, there's one right there, another one right here, and these represented some curb removal, for example. Okay, I can take both of these polylines. I could do select similars, anything like that. I could come up here and go to my curb and search for curb and find removal of curb. I can assign pay item, and when I do that, right then and there it assigns the pay item. If I hover over this polyline, I should get a tooltip. Tells me down there, pay item removal of curb. Okay, as soon as you have pay items assigned, you can run a takeoff and you can quantify those materials or those objects. So I've got removal of curb. I'll get to that one in a second. Removal of curb. Those are those two polylines I drew. Okay, so my focus here is to show you how to use it in corridors, but it can be used on absolutely anything. AutoCAD blocks, polylines, closed polylines for areas, you name it. And the value that it's going to pull out of that object is defined by your unit type over here. Okay, let's move on. Where do you define this stuff in your corridor? It's in your code set style. Code set style is based on codes in your subassemblies. So if we go take a look at my assembly here, say I want to quantify curb. Okay, my curb subassembly has a point code in it called back of curb. I need to reference back of curb and assign a pay item of curb, and then it'll give me a linear quantity. So this is a point code. If I take a point and I extrude it along the length of my corridor, that gives me a length, a linear quantity. So we reference point codes to get linear quantities. And then say, for example, I also wanted to get a pavement area. I would reference a link code. For here example, I have a pave link code. And the reason these are showing up, you don't get this in the out-of-the-box styles, I just have label styles turned on in my code set style. I've actually got another YouTube webinar that gets into that in detail, so check that out if you're not familiar with how to do that. Another question, will the QTO work with survey figures? Absolutely. Everything you create in here, it will quantify it. And I don't want to get into QTO Manager a ton, but there's other ways to kind of sort it and figure out what you've assigned a pay item to or not. It's a pretty nice little tool. All right, so we're going to go into our code set style. Edit code set style. And I'm going to edit my corridor design code set style. I'm going to make this full screen because there's a lot going on here. If I take a look at my point codes and I look at back of curb, there's that point code. If I come all the way to the right here, I have pay item. It's a little truck symbol here. I can pick on this. I can then sort by curb again, and I can find concrete curb, a pay item. Okay. I assign that. As soon as that's assigned, it will now quantify that in my corridor. What it's actually quantifying is that point code extruded along the length of all those baselines and regions in my corridor. In other words, it's quantifying the length of the feature line that's drawn by those point codes. I can do the same for, like I'd mentioned, pavement quantities or anything else, sodding, stripping, anything that is geometrically defined in my corridor. I can come to my pavement here, and I can grab asphalt, for example. And a lot of this is in tons. I'm going to grab this and I'll just grab this one. There's a ton of them in this out-of-the-box CSV. I grab one in square yards here. So I'll hit OK again, and hit OK again. Now the nice thing about this, you save those pay items in your code set style, and then modifications to your corridor are reflected each time you hit takeoff. So let's do this again. Takeoff, compute, and there's my quantities. There's those 200 feet of curb removal. There's 4,200 square yards of asphalt and 2,100 linear feet of curb. Now let's just do a quick check on that. Linear feet of curb. My overall distance of my corridor here is it's about 1,000 feet. I'm getting about double that. Okay, we know we're calculating the right thing. As you get used to this, you'd certainly want to do things like extracting polylines from your corridor, verify that it's giving you the right quantities. Another question came in, how would you handle a project that has both asphalt and concrete pavement? It's all about the codes, okay? So if you use sub-assemblies like this is the basic out-of-the-box lane. If you use this one for your asphalt concrete in one area, and then you use the same sub-assembly for your concrete in another area, the codes are going to be the same. So you have to get different codes in those different areas. Some of the answers are using, for example, a link width and slope. You can put that right on top of one of these, and you can have it follow the lane width and slope of this, and you can customize the code in here. Part of the problem with these is you can't customize these codes. You can build your own in Subassembly Composer, or I encourage you guys to check out CTC's Subassembly Productivity Pack. It has a set of common subassemblies with fully customizable codes in there. But short answer, you have to do it with the codes. You have to differentiate between the codes, because that's what everything is linked to. All right, so there is QTO Manager. You get linear quantities, you get area quantities out of this. Want to do a quick check of our area quantities. This is going to be pretty crude, but we want to verify that 4,200 square yards is roughly what we should be getting. And note that when this is quantifying, you see all those corridor links in there? Everywhere that those magenta lines running perpendicular to the alignment, everywhere that those are, it's using those to quantify the area quantity. So it's actually a lot more accurate than sample lines, which are just defined at some kind of interval, and I can add extra ones in there. But so here I take this polyline, let's look at the properties of it. The area of it is a whole bunch of feet. I can go right in my calculator, divide by 9, and I'm right in that ballpark of 4,200 square yards. So that's mostly what I wanted to show you guys today. Just a few conclusions to draw from this. I imagine people are all different levels watching this, but the big part of this is you have to model a corridor with more than your surfaces in mind. You have to be modeling what's out there. So one of the questions was, well, what if I want to do asphalt and concrete? You have to differentiate that in your corridor. That's done through coding, okay? You have to model what's out there. So the end game is not just a surface. That's just one output. The other outputs are quantities, like I said, construction documents. So it's putting more emphasis, in some cases maybe even taking more time to define that corridor model, so you get those main benefits from it. Those three things are surfaces, construction documents, and quantities. So the volumes dashboard, we looked at that. That's just lump sum volumes comparing one surface to the next. The material list, this is per station quantities when you need that, or if you want to pull quantities from your corridor shapes. Unfortunately, you can't reference corridor shapes in QTO Manager. I wish you could, nevertheless, it's not there. And use QTO Manager for linear or area quantities. I mostly focused on corridors today, but another great place for it is pipe networks. You can program that stuff right into your parts list. And then you can also use it to reference anything else, like survey figures was brought up, feature lines, polylines, AutoCAD blocks, you name it. Any type of AutoCAD or Civil 3D object, you can pull data out of it. And I didn't even quite get to it, but there's an option to put in formulas there. So if you want to take what's an area quantity and convert it to perhaps tonnage of asphalt, you can do that as well.